Today we're going to talk about Lewis dot structures. In a Lewis dot structure, we show an element's valence electrons and how they form bonding interactions with other elements in a molecule. To start, let's talk about valence electrons in atoms. Valence electrons are the electrons in an atom's outer shell. We can tell how many valence electrons an atom has based on its position in the periodic table. So, we know that boron, let's start from the other side. We know that fluorine has 7 valence electrons because it's one away from being a noble gas. Then we can go backwards. Oxygen has 6, nitrogen has 5, carbon has 4, and boron has 3. Then we move all the way over here to beryllium and magnesium having 2, and hydrogen and lithium and everything else in that row having 1. Everything in these rows has the same number of valence electrons. This goes back to its electron configuration. So if you were looking for the valence electrons for something in here, you could simply look at its electron configuration, and the highest orbital or shell that it has and the number of electrons in that shell would be its number of valence electrons. But since when we're talking about Lewis dot structures, we're quantifying covalent bonding, which is sharing of electrons between two atoms. We are usually going to look at the elements in those 4 rows that I've just highlighted. So, let's talk about how we would go about writing a Lewis dot structure. So, to begin with, we need to count the number of valence electrons of every atom involved. We can just simply look at the periodic table to do this. Then, what we'll do is we'll set up a shell where each element will go in relation to each other. This is usually something that you'll be given in courses. And then number 3, we'll create bonds and add lone pairs. So, let's start with an example. Let's start with this example right here. We'll start with number 1. So, our first example is CCl4, and we'll start by counting its valence electrons. We can go up and count 4 Cl and 1 carbon. So we know that we need 7 times 4 plus 4. And I'll spare you from doing that math. It will have 32 electrons. Now, we need to draw its backbone, or its structure. Since we know that it has 1 carbon and 4 chlorines, it's usually pretty safe to assume that we'll have a carbon with a chlorine on every single side of it. So carbon surrounded by 4 chlorines. And then we can get to adding our dots, since this is, of course, a Lewis dot structure. We'll add a single bond between everything. And so we'll add 8 electrons. And our options from here are to add double bonds now, or to add lone pairs. And the way we know that we shouldn't add double bonds in this is because of octets. Each element only wants to have 8 electrons. And in this example, carbon has 8 electrons around it right now. So carbon's octet is full, and we can't give it any more bonds. That means that we should put single lone pairs on chlorine. And in this example, if you put lone pairs on every chlorine all the way around, then that turns out to be 32 electrons, or 32 dots. And that's basically how you do it. You just make bonds and add lone pairs until you've used all of the electrons that you originally counted. So now let's move on to number 2, CO2. If we come up here, we can see that we need 1 C and 2 O's. So we need 16 valence electrons, 12 plus 4. And then we'll make our shell. We'll put carbon in the middle, since we only have 1, and an oxygen on either side. And then we can write that we needed 16 electrons. So, just like our last example, we'll add a bond between each element. And then we can think to ourselves, does everything have an octet? And the answer for this is no, carbon can still have an octet. So we'll add double bonds, because now carbon does have an octet and it has 8 electrons around it. But does oxygen have an octet? The answer there is no, because this oxygen right here has 4, and this oxygen has 4. So our next step is to add lone pairs. We've used 8 electrons and we still need to use 8. So we can give this one 2, and 2, and then give this one 2, and 2. And that is our 16 electrons, which means that this is the Lewis dot structure for CO2. Let's do our last example and talk about what we've learned. For our last example, we're doing CH2O, also known as formaldehyde. So we need to come up here. We need a C, an H, 2 H's, and an O. So we need 4, 5, 6, plus 6 is 12 electrons. So let's write that we needed 12 electrons. Our next step is to draw out what it should look like. We know that carbon will want to form a bond with oxygen and hydrogens. Hydrogens can only form one bond. They only have 1 electron, and they only want a duet rather than an octet. So let's start putting in electrons. We'll give everything 1 bond, and we know that just by doing that, we filled hydrogen's octet. So neither of these can be double bonds, and we can't give hydrogen any lone pairs. So where else are we going to put our electrons? We notice that carbon doesn't have its octet yet, and we can double bond it to oxygen. That gives carbon its octet, but we're still only sitting at 8 electrons. So how can we get rid of the other 2 electrons? The answer there is to give them to oxygen, which doesn't have its octet. So we'll give it 2 sets of lone pairs. And that is how you decide that that is the Lewis dot structure for oxygen.